This video is going to be somewhat a review of what we did today in class, which will be good for the people who were not in class today. And we'll also add some new materials. So fast forward where you need to. If you remember all of this from class, it's an opportunity to go over it again if you need some opportunity to review. So we're going to be writing and graphing functions today. So the first thing I want to do is go over something that we did back in 7th grade Excel, I suppose. I want to determine a relationship between the x and y values of this set of values. So then we're going to write an equation. So I've got the points 1, 3, 2, 6, 3, 9, 4, 12. And what I want to do is figure out what the relationship is between these values. So I'm putting them in a table so I can have a better look at what is happening to these values. And here we go, pen. Notice remember my input is my x, my output is my y. So if I put in a 1, how do I get out a 3? Well, I could add 2, and that would give me a 3. But then if I tried that with 2 and I added 2, does that give me my 6? No, it doesn't. So I must be doing something other than adding 2. So let's try something else. How do I get from 1 with an output of 3? Well, I could multiply 1 by 3, and that'll get me a 3. Let's try that again with 2. 2, if I multiply that by 3, that gives me 6. This looks like what I wanted. 3 times 3 will give me 9. So I have found my equation. I have the equation. Actually, we're going to write it as a function because we know how to do that. F of x equals 3 times x, because every time I put a number in for x, if I multiply it by 3, that gives me the output I was looking. Set of values in this chart, and our input value was 5, our output value is 1. Well, I suppose I could take my 5 and subtract 4. That would give me 1. Then let's try that with 10. If I subtract 4, nope, that's not going to give me 2. So let's try something else. How do I get from 5 to 1? Well, I could multiply by 1/5, and that would give me 1. Let's see what happens if I try 10 times 1/5. In fact, that'll give me a 2. 15 times 1/5 will give me 3. So all I'm looking for right now is to determine a relationship between x and y. So that relationship is 1/5 x. So we could write that as a function, f of x equals 1/5 x. Okay, so a review of what we did today. Remember, we talked about independent variables and dependent variables, and I've got a nice little chart that'll sum this up at the end. If you need to copy any of this down, please pause the video. All right, here were our examples we used in class. Identify the independent and dependent variables. I'm going to just click through this, so if you needed it because you missed class, please pause the video. Otherwise, keep moving on. Same example. So if you missed class, you need to be looking through this carefully and checking to see if this makes sense. The amount of medication depends on the weight of an animal. So my dependent variable is the amount of medication. My independent variable is the weight of the animal. Whatever it is that depends on the independent variable. Okay. So the dependent variable here, the cost to rent a jackhammer depends on the length of time. So the dependent variable is the cost. The independent variable is time. Remember, I've told you that time's going to be on my x-axis, and the x-axis is my independent variable. So this does make sense. Okay, here's my apples, my dependent variable is going to be the cost, and the independent variable is going to be the number of pounds. Okay, because the cost depends on the number of pounds I purchase. All right, so a quick summary that all of you may find useful. Independent variables, those are my X values. That's my domain. Those are my input. Okay, and then my dependent variable are my Y values. That's also my range, my output, and that's my f of x. Okay? All right, so an algebraic expression that defines a function is a function rule, and we've been doing this already, but this is just a slide that reminds you we've been writing things in function rules. Okay, we're going to identify the independent and dependent variables, then write a rule and function notation for each situation. A buffet charges $8.95 per person. What is my independent and my dependent variable? My dependent variable is the charge, so dependent variable is going to be the charge, and my independent variable is going to be the number of people, because the charge depends on the number of people. Well, how would I write this as a function? F of x equals 895 times my independent variable x. Okay, so this y, this output or dependent variable, depends on how many people my independent variable times that quantity per person. Moving company charges $130 for weekly truck rental plus $150 per mile. My dependent variable is going to be the total charge. And my independent variable will be the number of miles. Okay, and how will I write that as a function? F of x equals, so I've got this weekly charge no matter what, so $130 plus my output depends on how many miles. Remember, my independent variable is the number of miles, and each one of those miles is $1.50, so it's $1.50 times x. Okay. We're going to write a function to describe the situation and come up with a reasonable domain and range. So this goes back to on Friday when we were talking about domain and range. Remember, domain is which variable? It's the x, and your range is your y. Okay, so your input and your output. All of that is in your chart. Theater can be rented for exactly 2, 3, or 4 hours. The cost is a $100 deposit plus $200 per hour. Function to describe the situation. So f of, I'm going to make my x into h for hours, because the hours are what is our independent variable, right? So my function, my output, depends on the number of hours I put in. So I've got this $100 deposit plus $200 for the number of hours that I have. So here's my independent variable, the number of hours, and my dependent variable will be my cost, which I'm going to derive from the number of hours I'm renting it. Well, I can rent it. My domain is going to be, it tells me I can do 2, 3, or 4 hours. This is not an inequality. I've got specific amounts of time that I can rent the theater for, which means my range, I can input that 2, 3, and 4 into my function, and I will get out 2 times $200, $400 plus $100, or $500. I suppose I should put a dollar sign. I can put my 3 in. That's $600 for the hours plus the $100 deposit, or $700. And then finally, for 4 hours, that's going to cost me $900. So my range is 500, 700, and 900 given these limited domain values. There we go. Okay, so just a little bit of a review like the one we had in the slide today. I want to evaluate each function for the given input values. So here's my function, g of t equals 1/4 t minus 3. I want to know what g of t equals if t equals 31. All right, so now I want to graph a function with a particular domain. All right, so what I'm going to do is the following. First, I've got my domain, but I need to know what my range will be because I need both my x and my y value in order to be able to graph. So this is how I'm going to get my ordered pair. I'm going to know that my domain or my x values are -1, 0, 1, and 2. So my y, when I plug back into here, and in fact, I'm going to do this. I'm going to rewrite this in terms of y. So I'm going to subtract 3x from this side to move it over. So I get y equals 4 minus 3x. Okay, now I can plug in my x values. Plug in a -1. I'm going to get 7, plug in a 0, I'm going to get 4, 1 gives me 1, and 2 gives me -2. Okay, now I can actually graph those 4 points. It's going to look like this. Okay, now I have a very specific domain, so notice I am not connecting those points. This is a discrete graph. Now, in the second one, I have, remember we've looked at absolute value functions before. We know, spoiler alert, we know that it's going to look like a V. So I want to be able to find some value so that I can see what that graph's going to look like. So I'm going to go back to -4 so I can see a little bit more of what this graph looks like. And let's see what we come up with. Here are my x values, here are my output. It's going to look like this. And notice, I told you, spoiler alert, it's going to look like a V. Now in this case, my domain here, remember I told you if I'm not given a domain, I am to assume that the domain includes all real numbers. That means I can plug in any value for x and get out some value y. So if I can plug in any value, that means any point along this line is a valid value that I can plug in for x. So this is a continuous graph, and therefore I need to create a solid line, and then I put my arrowheads on the end to indicate that it continues in both directions. Okay, last problem. Function y equals 3x describes the distance in inches the giant tortoise walks in x seconds. I want to graph this function to come up with valid values for my x. They can't be negative, can they? But they could be 0, for instance. So let's go ahead and put in a 0, 1, 2, 3, 4, made it 5.5. So at 0, I haven't gone anywhere. I'm just plugging into my equation. Remember, y equals 3x. Look at the top. So this, what is that going to be? It's how far he's walking in x seconds. So remember, time is going to be on my x-axis, and on my y-axis I'm going to see how far he is walking. So that's going to be my distance. So here is my graph, and I want to know how many inches a tortoise will walk in 5.5 seconds. So at 5.5 seconds, I'm going to be just about here. So let's go up to, oh, my line is not very straight. Let's go up to here, and then I'm going to go over to my y-axis to see how far I've gotten in that amount of time. And again, the not quite so straight line. It looks like I'm going to go about 16.5 inches in that time. We will be continuing our review tomorrow. Remember, we have a quiz on Wednesday.